Hello, I'm going to demonstrate Newton's second law of motion. We see from this statement here of Newton's second law, when an object of mass m is acted upon by a net force F, the acceleration will be given by the equation A equals F over m, or acceleration is equal to force divided by mass. Now we can demonstrate that with the help of this air track, which is essentially a track with air coming out through some holes to allow for support of this car so the car can slide along in a frictionless manner. So here I have two cars. We'll call this mass, the mass of this larger car, we'll call 2 units of mass, and the smaller car 1 unit of mass. This has essentially twice the mass of this one. Now, we see that when we put these two cars together on the air track and let them exert equal and opposite forces on one another, the force on each will be the same. The magnitude of the force on each car will be the same as the force on the other car. And when I release this now by removing my hands, let's watch what happens to the acceleration. You can see 1 unit of mass will have twice the acceleration of 2 units of mass. Or 2 units of mass will have half the acceleration of the 1 unit of mass. And we see that that's consistent with the equation here, where the force is the same on each. If the mass is doubled, the acceleration will be half. And if the mass is cut in half, the acceleration will be twice as much. Now we can also see that with the cars coming at each other from opposite directions. Again, when they collide, the force on this one has exactly the same value as the force on this one. So the forces are the same on each, just oppositely directed. This has a force that's the same as the force on this one. And as they collide, those forces are the same on each. And you see the one with the greatest mass will have the least acceleration. The one with the smaller mass will have the greater acceleration. Again, Newton's second law.